Hello, everyone. Some new arrivals. There is a question up on the screen. Nice, easy, quick one. And if you have questions, you're welcome to ask, or you can type them. I don't mind either. And when you have an answer, can you either let me know or put it in the chat for me? We're just going to work through this question while we wait for everyone to get here. It's all to the whole of today's lesson is based on the stuff we've done in the last two. So you should be feeling really confident with reduction and co-ratios by the end of today. Hello. I was just saying to Nikayla, your mentor, before this started, that I'm sad I only have 2 more lessons with you because you guys are you've got such a great sense of humor as a group. I've really enjoyed our lessons together. But we only have this one and then the one on Thursday. I'm gonna have to say goodbye. Okay, so those of you who have just joined, there is a question up on screen. Once you have an answer, if you could let me know what that answer is or put it in the comments. I don't mind either one, just so I can get an idea of when you are finished. Don't forget to draw your Cartesian plane to help you. Oh, it's close. Just be careful about your quadrant. Okay. All right, guys, I'm going to leave this on for 1 more minute, just for those who have just joined, to at least give it a small attempt, and then we are going to move on to a bunch of reduction and co-ratio questions today. So many. It's going to be glorious. Okay. Marilyn, is it, so it's not about trig? Do you know what topic it's on? Nikayla might be able to answer that question better than I can, to be honest. But okay. All right, guys, I'm a video offing just so that I can turn my screen a little bit, and then let's get going with this first question. So firstly, if you don't have this from last week, I would like you to write it somewhere on a piece of paper as we move through today's lesson, because it's really going to help you. So we're just going to write our co-ratios down quickly. So if I have cos minus 90 minus theta, that's going to be equal to sine theta. If I have sine 90 minus theta, that's going to be equal to cos theta. If I have cos 90 plus theta, that's going to be negative sine theta. And if I have cos 90, oh, not cos, sine 90 plus theta, it's going to be equal to cos theta. Okay, so if you don't have these written down from our lesson last week, please make sure you have them somewhere now, because they will really help you with the lesson as we move through today. Then we need to think about our Cartesian plane. And remember that it's all students take care. And this would be 0 and 360, 90, 180, 270. Okay, so those are kind of our big things that we're going to be using in today's lesson. And I saw some answers that were coming in. A lot of you were getting it right, which is awesome. Let's start with the cos 90 minus theta. So cos 90 minus theta is that co-ratio up there. That's just going to become sine theta. And if I'm traveling 180 degrees and then plus another theta, that puts me into quadrant 3 where sine is negative. So that's going to be negative sine theta. And the sine thetas cancel each other out, and so our answer becomes -1. So a big well done to those of you who got that right. Someone got 1, I think, and I think what happened is you just didn't move into the right quadrant. So don't panic if that happens. Okay. Okay, great. Let's move on to some juicier questions then. Does anyone need extra time to write down these co-ratios over here? Just let me know. Okay. Good. Okay, cool. So for these ones, it's just a continuation of sorry, I just saw your message now. I think there was just a bit of a delay. Let me just put that. I think what might be quicker, if you need more time, guys, as we move down, just can you find the emoji where there's like the little hand up? And then I'll know that you're needing some extra time if I ask if you need time, if that is quicker or easier. Or you can unmute and just tell me, just be like, slow down, I didn't get time, I didn't get it down. Okay, so our co-ratios are definitely our friend as we work through these questions today. Okay, let's move down. Welcome to those of you who just got here. We are just focusing on co-ratios and reduction today. So basically, we're sort of cementing the work that we've done in the last 2 lessons. Okay, I'm not going to be too mean, so we're going to start with this nice question, and then we're going to move on to B, which is a little bit nastier. Let's see how this one goes. When you are ready, you can give me your answer either verbally. I love chatting to you guys, or you could put it in the chat, also fine with me, whatever you prefer. Let's reduce this and see what answer we get. When you're working through this question, I want you to just keep in mind what tan can become. Okay, still understand? Yes. Hi.
Hi. My answer is sine.
Is it sine or
Sine
is it? Okay, so sine alpha. I like it, but I also don't like it.
Yeah.
So there's a lot about it which is really good, and then there's one thing which is not what I want. There you go. You've been upstaged in the chats. Negative sine alpha. It was just a negative sign. So you just made a mistake with one of your quadrants. Okay. Let's make our way through this. Yeah, negative sine alpha. There we go. Okay. So we know that this is a co-ratio, and so we know that that's going to become cos alpha. And then if I'm traveling 360 degrees, All students take care. And then I'm going negative alpha. That puts me into quadrant 4. So I think what you did is you went positive alpha, which moved you into quadrant 1. And that was why you got a positive. I might be wrong though. And so then that became negative tan alpha. And tan, just remember that tan always can become sine over cos. So we're now going to change that tan to negative sine alpha over cos alpha. And those causes cancel each other out. And so we're left with negative sine alpha. Okay. Does anyone need to sit on this question any longer? Jolene, is the thumbs up, I'm happy and you can move on, or the thumbs up, I need extra time? No, I don't know. I'm never going to know. Okay. All right, let's, okay, thank you, Lisa. Okay, let's try B. Now, B is sneaky because of the squares. That is my little hint to you. Remember that when we're working with squares, we need to put things in brackets and then signs change. So just be careful with that. Think about what would happen if we square negatives, for example. Let's see what answer we get here. Ooh, okay. So Markley has an answer of 1. Let's see, does anyone agree with her? Does anyone disagree with her? Oh, another one. Okay, I think we just a little bit more time. I hope that you're feeling nice and confident with these questions. Okay, let's go. Okay, so 90 minus is a co-ratio, and we know that that's going to become cos x. So because our sign doesn't matter, we know it's automatically going to be cos squared x. Okay, that's our first situation. Then for our sine 360 minus x, we're going to travel 360 degrees, and then we're going to travel a negative x degrees, which puts us into quadrant 4. And in quadrant 4, sine would be negative. So what we're saying is we're saying that that's negative sine x squared. And because that negative gets squared, it becomes a positive. And so that lands up becoming cos squared x plus sine squared x. And that is one of those identities that we need to know. When we add them together, we get 1. So at the moment, the things that we need to know as we're working through is that tan, well, theta is sine theta over cos theta, and that cos squared theta plus sine squared theta would be 1. And so we can work backwards from that. So, oh, sorry. We could also say that cos squared theta is equal to 1 minus sine squared theta. So just keep these things in mind as we're working. This will be something that we're going to be using a lot in our lesson on Thursday. Okay, cool. Oh yeah, sure. And Marilyn, which part? So from the beginning or these identities on the right? I think I'm meaning this part here. Okay, perfect. Let's just go through it step by step. Okay. So our first step is to think about this sine squared 90 minus x. And we know that 90 minus x is one of our co-ratios, okay? So that's one of these situations over here. And so we can jump straight to saying, I could put it in brackets if I wanted to. So just for the sake of consistency, let me put it in brackets for you. That's the same as me saying sine x squared because of that square over there. Then I'm looking at this right-hand side and I'm traveling for sine. I'm traveling 360 degrees, which takes me all the way back to my origin. And then I'm minusing x. And because it's a negative, I'm going in the opposite direction. Okay, that puts me in quadrant 4, where sine is going to be negative because the only ratio that's positive there is cos. So I have negative sine x, but again, it's being squared. So I'm going to have my square. Now, sine x squared, I can write that the same way as saying sine squared x. Those two mean the same thing. Then when I work on my second one, I'm squaring this negative, and a negative times a negative becomes a positive. So this just becomes, oh, sorry, that should be a cos. Why did none of you correct me? Just letting me talk here like a lunatic, okay? Then this sine squared becomes plus sine squared x. And when we have cos squared x plus sine squared x, that's just equal to 1. I hope that makes more sense, even though I made it more confusing by putting in the wrong trig ratio. But I hope that it does make some kind of sense. Okay, but we're going to be practicing these so much today that by the end of today, you're going to be smashing it. Don't you panic. Oh, look how juicy they're getting, guys. Oh, I'm so excited. I've got some right at the end, which are like worth 7 marks in an exam, which I'm very excited for us to get to. But you see, it is. You've just got to think about it step by step. Like when you work through these, when you look at it, you can't let it scare you. That's the most important thing. You've got to show this trig who's boss. And you look at each thing independently. So you look at that. Don't look at the rest of it. And then you look at this. And then you look at the tan. Like look at each thing step by step. Don't let the question scare you. Let's see if we can get let's see if we can get some positive answers happening here, or negative. We don't know. Don't be scared of that square. Just think about what we did in the previous question. You should get quite a nice answer here. I'm not going to do the whole thing. I'm going to do one step at a time. Just for those of you who are feeling a little bit overwhelmed at the moment, I don't want you to look at this and like just give up. So I want you to just focus on this. For example, if you're one of those people who are feeling like I have no idea what's going on, then listen. If you are comfortable, then don't listen to what I'm going to say. Well, you can listen, but you don't have to. Okay, so if I'm just looking at that cos, I'm traveling 180 degrees. Then I'm traveling a negative degree. So I'm going into there, which puts me into, yes, that answer is beautiful. Sorry, it was just a direct message. That puts me into quadrant 2, and in quadrant 2, cos is going to be negative, okay? So if I'm writing that, I would write it as negative cos beta squared. And then think about what that negative will become. So you're just going to do it step by step, one thing at a time. Then think, what is that going to become? Then think, what is this going to become? One step at a time. And when you are happy with your answers, you can let me know. You can chat to me. If you have questions, ask away. If something's feeling really confusing, just let me know. So the reason the brackets are necessary are because otherwise we're not going to be squaring that negative sign. But generally, if you can jump straight to saying cos squared b, then you wouldn't need to have the brackets. Okay, I know that sine 90 minus beta is going to be cos, oh, wrong color, cos beta. So I can put that in. Okay, and then when I'm looking here for tan 180 plus, I'm going to go 180 plus, which is going to put me into quadrant 3, and tan is positive in quadrant 3, so that's going to be tan beta. Okay, and then I'm going to square this, so this negative is going to become a positive, and so that's going to become cos squared beta over cos beta times tan beta, and tan beta we can change to being sine beta over cos beta. This is where it becomes very satisfying. That cos squared will simplify with those two coses at the bottom, and so our final answer is just sine beta. How awesome is that? It's like very exciting when it all comes together. Now, if you were being marked, if this was in a test situation, you would get a mark for getting to that cos squared beta, a mark for that cos beta at the bottom. You'd get a mark for having tan beta, a mark for converting tan beta to being sine beta over cos beta, and then a mark for your answer. So you're looking at 5 marks overall for a question like this. Oh yeah, that's absolutely fine to change it in the first step.
Ma'am?
Yeah.
So did the square cancel the negative in the bracket?
Yeah, so the negative lands up becoming a positive because I'm squaring it. So basically, if I rewrote that, I'm writing it as negative cos beta times negative cos beta. That's what that means. And so those two negatives become a positive, and that's why it goes away. Basically, though, anytime you see you have a squared situation, you can know it's going to be positive, regardless of if it was negative or positive, which is like a nice trick for you to know. So you can just jump straight down to that step over there if you wanted to. Okay. Does anyone need to sit here? Okay. Jolene with that thumbs up again. I don't know what it means. I'm gonna do this. I mean, you can see both, and then I'm covering my bases. Okay, for D, it's actually quite similar to one that I gave you right at the end of our lesson on Thursday. So you should feel quite comfortable with a question like this. We're moving away from our theta, alphas, and betas now into numbers to see how that goes. So give that one a try for me. You should get a nice, it shouldn't take too long, nice, easy, quick answer. Okay, thank you, Jolene.
Ma'am,
Yes,
I'm getting here we're gonna change either one of them from like 90 minus.
that's
No,
sounding good. That's sounding really good. Sine 90 minus 57. That's excellent.
they're gonna cancel each other out, right? Yeah.
Beautiful. So that's
Oh,
sine
yeah.
90 minus. So what's this going to become up here?
Then it's going to be cos 67.
Yes. And so what's my final answer going to be?
I think it's 1.
It's 1. Beautiful. Yay. Oh, I got so excited. I moved the whole screen around. Exactly. It's going to be 1. Beautiful. Nice job. Okay, so I'm just looking at some questions over here. So it wouldn't be tan 57 because it would only be tan 57 if I had sine 57 over cos 57. Then that would be equal to tan 57. But because this is sine 33, it actually becomes cos. Okay, great, good. Okay, let's go on to another one which has some numbers on. I'm going to just try and fit both in case people are still working. Now remember, I have to get nasty at some point. I've tried to ease you in, but these questions make up the bulk of your trig in your exam at the end of the year. So knowing reduction in co-ratios is very helpful. When we're working with numbers like this, remember, we're going to try and get the numbers to be around 360 or 180 when we're working with reduction. But if we need to use 90, we can. And because we can't deal with special angles here, we want to try and find an angle that both of these will have in common. So try and keep that all in mind as you work through it. I know that it's a bit nasty. Just give it your best go. I'm going to give you a couple of minutes because I know this question's quite hard. My hint to you to help you here is the angle 38. That's my hint. And you should get a very nice answer. If you're not getting a nice answer, then try something different. If you need help, let me know. I'm here. No answers coming through just yet. I know it's a mean question. I lost you with the hint. The hint was I thought it was helping. We're trying to find an angle that we can make both of these things have in common. So we're going to use reduction where we can get the same angle in both. And that reduction, my hint to you is that in the reduction, we're going to be using the angle 38.
So it's going to be sin 38, right?
For your final answer.
Not the final answer. but
Okay, it will definitely, yes, sin 38 will definitely be in there somewhere. So for example, okay, I'm going to help you a little bit with this goal. I'm not going to do the whole thing for you. This would be a negative, so because that's that negative. I could rewrite this sign as sine, sorry, I don't know why I'm making a square bracket, 360 minus 38, because 360 minus 38 will give me 322. And then I could write this cos 128, this situation here, I could write that as plus cos 90 plus 38. And now all of a sudden, I'm seeing I have a 38 there and I have a 38 there, which means that I can make something in common. That should help. You see, so my hint was trying to help you. Lisa, where are you lost from with this step here, with this green step? Oh, you're not lost. Okay, excellent, great, good, okay. So now try and work it out from this step here. It's okay. Yes, that's absolutely right. The answer is 0. Yes. Okay, so let's have a look. We're going to have, I think what happened with some people was they forgot about this negative over here, but I'll show you exactly how it's going to come into play. So we've got our little Cartesian plane. Okay. I'm traveling 360 degrees and then I'm traveling negative 38. And so in quadrant 4, sine would be negative. So this becomes negative sine 38, because the negative is because of the quadrant it's in, and that negative was the original negative that I was eating. Okay, so that's our first step. Then we look at cos. This is a co-ratio. It's our nasty co-ratio that becomes a negative. It's the only one that becomes a negative. So this is going to become negative sine 38. Then this negative and this negative are going to become a positive. That's going to become positive sine 38 minus sine 38. And anything minus itself is 0. So I think what happened to a couple of people was that they forgot about this double negative over here. And so they were getting negative sine 38 minus sine 38. And then things weren't simplifying. But I hope that this makes a bit more sense now. Okay. Cool. Okay. Before you jump into this question, I want you to think about things logically, okay? We know that our goal in these questions are to cancel things out. So we need to think about this cos 68 and this sine 22 and think about how we could eventually work with those to cancel them out. So just keep that in your mind. And then remember, you're just working through everything individually. We don't let these big questions scare us. You're going to work out that. Then you're going to work out the cos 68. Think about what you want it to become. Think about your sine 22. Do we want it to stay the same or do we want to change it? Then think about that cos 360 minus alpha, one step at a time. And our goal is to cancel things out. So what can we do that can cancel? I'm just going to put another hint here on the side. Yes. Oh, I see there's a question. How can I help?
I have an answer.
Oh, you have an answer already.
Mm,
Okay. Tell me what I would do. How would I start?
It's sin 180 minus alpha cos 68 over sin 22. And then you're gonna say, I'm gonna sin 180 minus alpha is positive. So
Good.
the
Good.
using alpha, and then the cos you're going to say 90 minus 22 over. Oh no, yeah. Cos
Yeah, that's right.
90 minus 22 over sin 22,
Nice.
and then it's times cos alpha,
Beautiful.
and then
Okay.
the next step we're going to say 60 sin 22. Sin
So,
alpha times
yeah. Nice. Okay. Over
over
sine.
sin 22 cos alpha, and then
Yeah.
the sine 22 they cancel each other. They cancel each other out, and then it's going to be sine alpha over cos alpha.
I love that. But what is sine alpha over cos alpha?
It's 10. It's 10.
Yes, there you go. And that's our final answer. Well done. That was so beautifully said. Excellent. Well done. What a great answer. And so again, in these questions, guys, you get marks for every single step. So you get a mark here for the sine alpha. You get a mark here for showing you needed to know reduction co-ratios. Here, you would get a mark for simplifying. So for canceling those, you would get a mark for that cos alpha over there, and then a final mark for your tan alpha. So you're looking again at 5 marks for a question like this. Oh, it's so nice when you just get those marks in trig and everything sort of falls into place. Very exciting. Okay. I'm wondering if we can go, I'm just looking at our time. I'm wanting us to go to a little bit of a nastier question because I want to show you one other thing before we move on. Okay, so let's do this question, because I think that it will be uglier for you. So this type of question, because I'm so kind, this type of question they would say solve without the use of a calculator. And so basically what we're looking for is we're looking for special angles. Okay, and remember with special angles, we're looking for 30 degrees, 45 degrees, or 60 degrees. So keep those in mind as you're working through this question. Try and reduce it to get those special angles involved. And let's see what our answer looks like. And then I'm going to show you one other little thing before our end of our lesson today. I'm not going to give you your answers. I'm just going to help those of you who are struggling a little bit with figuring out how to reduce these numbers. So we're just going to do it step by step. So for those of you who are confident right now, you don't need to listen to me. I want to break that down to have either 360 or 180 at the beginning of my bracket and then a special angle next to it. So I'm going to break that down to saying that sine 180 plus 60, because 180 plus 60 will give me 240. Okay, next, cos 300. I'm going to break that down and say that that's cos 360 minus 60. And our next one, sine 405, I'm going to break that down to say sine 360 plus 45 degrees. And all of those are special angles, so we're allowed to use them. This is my way. Okay, then we move down to our denominator. Tan negative 120. Now that's ugly, but remember, we don't panic. We just say, well, that would be tan negative 180 plus 60. Easy. Next, cos 225. We could write that as cos 180 plus 45. So our first goal is to write everything with either a 180 or a 360 at the beginning where possible. Sometimes we have to use 90, but we try and avoid it because then we're going to have to do a co-ratio. And then we can just look at our Cartesian plane to see what things are going to be, what values each thing will hold. Okay, so I'm just going to give you a couple minutes to finish that off, for those of you who are struggling with that first bit. Okay, so my first one. Our first one, we're traveling 180, and then we're traveling 60 degrees more. So that's going to become negative sine 60, because we're going to be 180 plus a little bit, puts us into quadrant 3. Cos 360 minus 60, 360 will bring us back to the beginning. Minus 60 puts us into quadrant 4, where cos is positive. Okay, 360 plus 45, we're going to go all the way back to the beginning. Plus 45 puts us in quadrant 1, where sine will be positive. Sine 45. All over tan negative 180. Remember, just means we're moving anti-clockwise, but it's the same thing. Plus 60. So move back down into quadrant 3, where tan would be positive. And then cos 180 plus 45, we travel 180 degrees. Plus 45 degrees puts us into quadrant 3, which means that that will be cos 45. Okay, now at this point, if any of you got there, you are sitting on 1, 2, 3, 4, 5 marks if you're sitting there. Okay, now everything is in special angles, which means we're allowed to move into our calculator. So now you can put into your calculator what is sine 60, and you'll see that it is root 3 over 2, but remember it's a negative, so we're going to say negative root 3 over 2 times cos 60, which is a half, times sine 45, which is root 2 over 2. And all of that is divided by tan 60, which is root 3, times cos 45, which is root 2 over 2. Okay.
Ma'am,
Yes.
at the cos 45, isn't cos 180 plus 45, isn't it going to be negative?
180 plus 45, you're absolutely right. That is definitely going to be negative. Thank you. Thank you very much. That will definitely be a negative. Okay, beautiful. Thank you for that. This is where it gets a little bit nasty, and it depends on how much time you have in your exam, is my advice to you, is that because this question said that we need to do it without a calculator, if we put all of this straight into our calculator and get an answer, that's fine, but you are going to lose a mark. So now, if you're running low on time, then my advice is definitely just put it into your calculator and get an answer. If you have time, then rather write what you're needing to write. Okay, let me just see for the tan. You got tan 30 because you added 150. Okay, so if you had the problem with the 150 is it's not one of our axes. So we're wanting to use either 90, 180, 270, or 360 when we're using reduction. So for 150, it's not one of those axes that we can play with. That's the only reason. I see a hand up. Is that a question?
Ma'am, at 10:45, can we write 1/2? Oh, 1/2.
For cos 45?
Yes.
Yes, absolutely.
Even at 10:45.
Yes. So all of these have just been rationalized. So you definitely could write that as 1/√2. Okay. So now at this point over here, if you were wanting to do it without your calculator, you would look at your numerator and then you'd look at your denominator. First of all, I can see that both of those negatives are going to cancel and they're going to become a positive. Great. Okay. My numerator, I'm going to have √3 times √2 because it's times 1 over 2 times 2 times 2. So 2 times 4, 2 is 4, 4 times 2 is 8. And then I'm dividing that by √3 √2 over 2. Okay. So that's our first goal. Then, because it's a fraction, this is why I'm saying this is not worth your time if you're running low on time in a test. Because it's a fraction, we're going to do it tip and times. Times. These are going to cancel with each other. We're going to cross cancel our 2 and our 8, and we're going to get an answer of 1/4. So if you are in a situation in your test and you are struggling for time, the most important thing is that you've got into this step over here. And then if you put it into your calculator and get a 1/4, that's absolutely fine. If you have time and you're wanting to make sure you get all the marks for the question, then you need to show this working purely because they said in the question that you couldn't use your calculator. So even though we're using our calculator, we're using it sneakily. Lisa, do you have a question?
No. Yes, I do have a question. And how do we get to the square root of 3 and get it to over 3?
This part over here.
Yes, ma'am.
Okay, so all that I did was, yes, I can absolutely explain these steps. So the first thing that I did is I looked at the signs. So this negative and this negative, they would cancel and give me a positive. Okay, so I don't need to worry about them anymore. That just makes my life easier because I don't need to think, oh, is this going to be negative or positive? Then, like any fraction, like if I had 2/3 times, let's say 1/7. Okay, when we're multiplying fractions, we multiply our 2 tops together. So 2 times 1 is 2, and we multiply our 2 bottoms together. So 3 times 7 is 21. So that's exactly what we're doing here. I'm looking at my numerator. I'm saying √3 times 1 times √2, and that would just be √3 times √2 because it's times by 1. And at the bottom, I'm multiplying my denominators together. So 2 times 2 is 4, times another 2 would give me 8. And then I'm writing it as a divide instead of making it a fraction. So I'm just saying, well, that would be √3 times √2 over 1 times 2, which is 2. Okay. Okay. And then our next step, we changed this divide to a times, and we flipped our fraction over. That √3 and √2 will cancel, and our 2 and our 8 will become 1/4. Okay. Okay, one more type of question we're going to go over, which is like the last type of question they can ask in these reduction questions, is when they bring other letters in. So this is like as hard as these reduction questions can get, which is why I wanted us to do one before the end of today. These questions are ones that often come up, but it looks much more complicated than it is. Oh, my spelling, look at how I have spelled calculator. Okay, it's just a calculator. There we go. Okay, in this situation, instead of dealing with a special angle or dealing with a theta or an alpha or beta, we want to be focusing on the angle 12 degrees because we know that sine 12 degrees is m. Okay. So before doing anything funny, let's just quickly remember, I think it was our first lesson together when we looked at Pythag and we drew ourselves that little triangle. Okay, and now we're saying that that's our 12 degrees, which would make our other angle 78 degrees. And we're going to do this whenever we have a question like this. We start the question just by drawing off our triangle so we know what's going on. Now, if sine 12 is m, if I wanted to write that as a fraction, I could write that as m over 1. And here's my 12. And sine is opposite over hypotenuse. So that would be m and 1. And then using Pythagoras, this down here would be 1 squared, which is 1 minus m squared. Okay, so before we do any other questions, we just do our little triangle. Sometimes it helps us, sometimes it doesn't, but it's always good to have. Okay, so I need suggestions. How can I rewrite this 102 degrees to get a 12 involved somehow? How can I rewrite this?
Ma'am, I think it's going to be cos 90 plus 12.
Excellent, cos 90 plus 12. Very, very good. And what is that going to become? So that's going to become negative sine 12, because that's our one coratio that becomes negative. Good. And we know that sine 12 is m. And so we know that this is m, which means our answer is negative m. So these questions are wanting us to use what they've given us in the question. So can you please give B and C a try for me? Think about how you can reduce that 192 to have a 12 involved.
Ma'am, so that means even if like the answer, like you see that negative sin 12, it can be negative as long as it has that m, that sin 12, as long as it has it can also be a negative or positive.
Yeah, so the thing is that this sine 12 here, that's what m is, right? And so we know that that's m. But because there's a negative sign, it's just going to become a negative m. That's the only reason. We're just carrying that negative down. So how could we rewrite sine 192? How could I use my reduction to get a 12 involved in there? Yes, there we go. 180 plus 12. Nice. Okay. And then think about your Cartesian plane.
It's going to be negative sin 12.
Good. It's going to become negative sine 12. And we already know that negative sine 12 is negative m. Happy days. Great. Yes. Look at these answers. Great. Okay. Now cos 12, we actually don't need to do anything fancy because we were smart and we drew our picture right in the beginning. We drew our triangle up here. And so if I was looking at that, can you tell me what cos 12 is going to be? Because you have it all in your picture. Think about what cos is. Cos is going to be adjacent over hypotenuse. So my adjacent in this case is my root 1 minus m squared, and my hypotenuse is 1. I don't need to write the 1 if I didn't want to, but you can. Okay. I'm actually going to miss this tan 12, and I'm going to jump down to these ones just so that we're going to just milk every second we can from this lesson, guys. Okay. I just want you to think about this. I'm going to help you just because we're low on time, and I'm going to draw your triangle for you. And I want you, while I'm drawing this triangle, to give the first few a try for me. So if I'm looking at this first one, which was sine 42, because we took time and we drew our triangle, we can just look at where that 42 degrees is and say, well, what's our opposite? Our opposite is root 1 minus k squared. That's our opposite. And our hypotenuse is 1. So that's our final answer. That's all we have to do there. We didn't have to do anything fancy. Now for cos 48, we do have to do something fancy. How could I rewrite that cos 48 to have 42 involved? What would I say in my brackets?
-42.
Yes, 90 minus 42. Good. And what's that going to become?
It's going to become a
So that cos is going to change that to sine 42. And we now know that sine 42 is root 1 minus k squared. Okay, I'm just going to go through this last one. I know I'm rushing you guys. We'll start our next lesson on Thursday just with a question like this, just so that you can cement it in, and then we'll move on to identities. I could rewrite this tan as tan 180 plus 42. Then I'm going to go into my Cartesian plane, 180 plus 42. All students take care. Tan is going to be positive. That's going to become positive tan 42. And if we're looking at tan 42, we can look in our triangle. There's our 42 degrees. Opposite is root 1 minus k squared, and adjacent is k. So that would be our final answer. Okay. Unfortunately, our time has run out, but I promise we'll start our lesson on Thursday with a question like this, because I know it's been rushed. And then, yes.
Ma'am, on at B, why didn't you write it over 1?
Oh, you don't have to. So I could have written it over 1, but it's the same as if I had like 2 over 1. That's the same as just saying 2. So I can write the 1, but I also don't have to. Okay. And I'm going to pass you on to Michaela, but I hope you all have a lovely, lovely evening, and I will see you on Thursday.
Hi, guys. Well done on all your hard work today. Yeah, I think you guys are doing really well. And I'm just going to go into our homework and give you some updates. So unfortunately, we're going to have our last lesson, which is trig identities on the 9th, which is later this week. And yeah, I think this was a bit short of a lesson, the trig part, but I think you guys have made so much progress. So well done. Okay, and we have our leaderboard. We haven't had it in a while, but we have a lot of ties. So we have Tokozani and Oratiwe at a tie for number 1 with 6 lessons. And then we have quite a few people at number 2. We have Rile Bohile, Joy, Nolene, and Bokang at 4 lessons, and then Marilyn at 2 in 3rd place. So well done, everyone. Keep up the good work. And yeah, maybe in the next few days, as you guys get the homework and stuff, you can start practicing even more towards the end of the week. So well done, everyone. Okay, and now for your homework, we're going to go and look for the topics. You're going to look for trigonometry. Once you click in, you're going to look for reduction, and then reduction of co-ratios 90 degrees. So that is your homework. I'm just going to leave it up for everyone as usual, so you can take your pictures or write it down. Also, a quick reminder, we're going to be launching some cool stuff on our social media. I think it is Facebook, Instagram. Just make sure you guys are subscribing on YouTube as well, and liking our pages and following us on Instagram and Facebook if you use Facebook. So yeah, just keep your eyes open for something that might pop up. But yeah, if you are following us on social media, you'll probably get updates a lot more. So yeah, there's also a lot of nice content on YouTube that could help for studying and tests. So yeah, well done everyone, and hope you enjoy the rest of your evening.
Bye, everyone.